up.
Yeah, like the archetype. Well, no, the archetype though is like one of like, correction and introspection,
correction,
and
anthropomorphism,
and it's kind of like, yeah, like like personified. It's like that's how the ancients looked at it, and it's kind of interesting that as an archetype, it's like a corrector, like it's a judgment, and like they tried to remove it, which is kind of just interesting if you look at it on a like people that even believe they're on a globe or whatever the fuck, like look up their horoscopes. They follow their horoscopes and shit. They believe in that. And like all I'm trying to say is like
astronomers are so famous for is believing in astrology, right?
Well, I mean, people. I'm sure there's astronomers that check out their astrology in the newspaper, or something. But my point is that there's like this tie-in to this archetype of Pluto, and the idea that they would try to kind of remove that from the, let's say, like the mass subconscious, the collective.
I think you're the only one trying those.
Do you think that I'm the only? Hold on. Do you think that
it's just that as they were able to see more clearly into our solar system, they realized that there's also about another 30 objects where if you classify Pluto as a planet, you would have to classify those other 30 objects as planets as well. And they thought, well, we can add 30 more planets to our solar system, or we can just take one out.
Yeah, we get it. But let me ask you a question. Do you think the kind of stuff I'm talking about, do you think that nobody thinks about that?
I don't think the scientists are all Jungian philosophers. No. I'm sure somebody thinks about that, but it's mostly going to be people on your side of this conversation.
Well, I mean, it is interesting.
I think are just people that sit in empty fields in the middle of the night with telescopes.
Well, no, actually, didn't the guy who created Jet Propulsion Laboratories hang out with Aleister Crowley and do all kinds of fucking shit with him?
He did. Yeah. He also occasionally did some science.
Right. They were into that kind of stuff. You know what I mean? They were into that kind of stuff, right?
You know where Pluto came from? Disney. You don't think that the little puppy dog and that cartoon and the founding of Pluto have any connection whatsoever at the same time?
Yeah, I think Walt Disney is actually a time traveler, and he was actually back in time, and he was actually...
They were well known to be connected, man.
No, hold on, but Jack Parsons hung out with...
Disney.
Jack Parsons hung out with Aleister Crowley, right? You guys know that?
Yeah. Two good men were friends.
Yeah,
right. And I'm just saying, they would be the type of people that would think about this kind of stuff. You know what I mean?
Werner von Braun, the ex-Nazi, great guy.
The guy who converted to Christianity, who's got a Bible verse on his gravestone,
saying there's a dome. Yeah, saying there's a dome.
To say this shit.
It says there's a dome. The firmament, like it does in the Bible.
Yeah, the firmament. The Riksky.
It mentions
the fucking dome.
Yeah.
And it's also the German Bible, which translates differently. So
that's not a dome. Firmament does not mean dome.
Exactly. So he makes a biblical reference, and all the atheists are basically so proud of him. What's going on?
Yeah, I'm proud of lots of religious people that are able to put away their religion and focus on the science. I'm very proud of those people.
Well,
sometimes the two connect, sometimes they don't connect.
Well, yeah, dude, at least you guys have the state on your side.
Are searching for God by understanding the natural world, and by trying to search for God by understanding the natural world, they discover things. And we make those discoveries.
That's good. You guys got the state on your side?
You got all state on your side here. Hold up. But there's a fallacy here with the physical dome being necessary, whereas energetically and by temperature and by density and by these various different things and by different changes, transforms in the material qualities of different gases, that they can form effectively a dome, if you like, or a flat. I mean, there's no. To me, that there's no if there is some kind of a dividing going on there, where's the evidence that it's? What do you think about that, Glober guys? Glober fellows?
No, it's the flat earthers that think it's a physical material.
No. We don't. Take the crepuscular rays and shit though. What about that? That could be evidence for
Do railroad tracks converge?
Let's say.
Do railroad tracks converge?
Anti-crepuscular rays, everyone.
Yeah, well, crepuscular and anti-crepuscular.
I'm just saying.
I'm just asking if railroad tracks converge.
Physical dome.
Are you that retarded? Are you that retarded?
You took a hard turn into a whole different subject.
I don't know why you're asking me if
Am I
I'm
retarded?
retarded when you say
Do
you see
railroad tracks
corpuscular
converge,
rays,
guys?
and
I
then
don't know.
Do I
and then
converge?
I don't know if
and you
railroad
know
tracks
for a
converge.
fact
Do the
that
railroad
Yeah,
tracks
are
definitely
also
lead
monorail.
into the Plato's
corpuscular,
cave?
and
Okay.
you don't want to answer the
Yo,
question if
dude, if
railroad
you need
tracks
those kind of
converge.
answers, this might not be the place, man.
It's kind of funny.
Yeah, that you
Yeah,
don't
and do
know.
flat roads
You don't know if
rise
they
in the
converge or not.
distance? Another one of the optics.
That's how
So
they
I'll
got the
present his
monorail,
point
he
not
said.
as a question, but just as a statement. The parallel light that that appears to us to converge is converging because of perspective. There you go. Since he
Amazing.
got
And so
triggered
can
by
you
it
make
being a
any
question.
conclusions at the nature of the occlusion from the bottom up of like ships going over the curve and how light
Like
bends?
corpuscular rays? No, nothing to do with them.
Anti-corpuscular rays, you're not willing
Yeah,
to
no, it's
consider
your
that
only
either?
evidence for sphericity that you have is
Nothing
like
to do with
stuff,
that either.
and it's really
Corpuscular
just
rays? No.
inconsequential. Yeah, it's the only thing you have that it looks like it's curving.
Corpuscular rays have nothing to do with. What are you talking about?
Yeah, exactly. There's
How are
no
you
curve
linking
on the
these two?
Earth. Your only observation comes from stuff like that. That
There
would
is, but
person.
it's nothing to do with corpuscular rays.
Well, no, the only reason you think it's a globe is because of the optics, like
Because
corpuscular rays, and then you try to use
uh,
that maybe as evidence for the globe. Even who knows?
not everything you can see with your eyes or use optics to look at means optics. You can't just lump everything into a category of its optics, just like corpuscular rays, because we look at them.
Yeah. Well, all right. Do you know you can't put the connection together and how that would tie together?
I can't. I'm very poor at mental gymnastics. I'm sorry.
Okay. Fair enough. We see that a lot in here.
Parallax measurement, Reds and Astronomy Live did to figure out the distance to the ISS.
Yeah.
So, does anyone think those measurements are valid?
I did
Yeah.
my own observations, so I always observe the Earth to be flat. I always observe surfaces of bodies of water to be flat. I always observe the horizon to be flat. You do too. You do those same observations for me. So you're observing the Earth being flat for me. And no, I'm not asking you to observe the thing, and I'm not believing that the earth is flat. I just see the thing. But you say, oh no, we all observe the earth to be flat. So it's an objective reality. It's not subjective. But we believe it to be a globe. So you see it flat, but it is a big globe. Something that you never observed. I never observed that too. But you believe those people, those who shows the video, that gives you the data, who gives you those testimonies. I don't do that.
Did you measure it or did you just observe it?
Yeah, because I did measurements, my guy. I did measurements.
You did calculations. You know you did calculations. Stop lying.
I never did measurements, I know. The surface, yeah, I can say that those observations, I can consider them measurements. Okay, Merlin guy, let me ask you just this clarifying question so I know that I'm not wasting my time. Are you saying that trigonometry cannot be used to quote unquote measure something? So if I have a parallax value to a particular object, I won't be able to use that parallax value, the measurement of that parallax value, to figure out the distance to that object? That's okay, take your time.
Can I comment on the notion that you think you're wasting your time just because of this conversation, yet you've sat here for hours on end? Are you still wasting your time, or what's the go?
Oh, I'm wasting my time now because it seems to me like you're not willing to answer that question.
Well, then you're just wasting your time, bro. So, I mean, why are you here?
So I think I got all I needed. So maybe this wasn't a waste after all, because
Well,
since
wrap it
you're,
up. You ain't got nothing.
unable to answer that question, what does that tell you?
I mean, it wasn't a
What does that tell
question
you,
for
my
me,
guy?
so it's someone else. He's like, you can wait for his answer.
No, I was asking you, my guy. I was asking you because you said
because I'm
you
the
don't have
Merlin
measurements,
fella.
you have
Okay, my bad.
calculations.
Yeah, dude, are you not passing it through some sort of formulation at the end after you do your measurement?
Does that make it less empirical?
Yeah, it
What's
bakes
your
in the
measurement?
calculation.
How the
You're
fuck
baking
does
in
that work?
You're
my guy?
measuring
you're
an
baking in
angle.
you're baking in your interpretation just by
So,
doing a
so
calculation, and you call
trigonometry
it a
is less
measurement. You cook
empirical
cat.
because reasons. What makes trigonometry less empirical? Please explain this to me.
Is it true trigonometry or is it?
Oh, now there's
trigonometry?
the
Tell me.
difference between what's the distinction between
Is there
true
or is it? Which one
trigonometry
is
and
it?
non-true trigonometry?
I didn't
Is it
say true or not
exact
true.
on a
Is it
wavy
spherical or
surface
non-spherical?
while you're taking an angle over that surface? Is
I was
that
not
angle over that
talking to
surface
you.
the same as the surface itself? That's what you should ask yourself.
Cool.
Well,
I
that's
wasn't
not the
talking
question.
to
We're
you.
talking about
So
parallax.
back to the Merlin guy. So what is the difference between, quote, true trigonometry and not true trigonometry? Define the difference for me, please.
Is it spherical trigonometry or is it what? Nominal, like standard trigonometry? Which one are you dealing with?
So are you saying that non-true trigonometry is any trigonometric measurement
When
made
did
off
you
of a
hear me
sphere?
say
Is that what you're saying?
non-true? When did you hear me say non-true? Which one?
Well, you said
Which
you
time?
asked me, is it true trigonometry? That must imply the existence of non-true trigonometry, right? Or were you
And then
full of
he
shit?
I said, is
specifically
it
asked
spherical
you.
or standard?
Okay,
Yeah.
so
See, again, he's talking about true and not true, and now you're talking about spherical and not standard. So you're relating spherical and not spherical and standard versus true and not true. You're the one doing the relation.
yeah, so please explain the difference.
If I said it's not true spherical trigonometry, my bad.
Oh, for fuck's
No,
sake. Okay,
you're not saying it. You're relating it.
Tell you
When we
what I
asked
did,
you
and you
about
tell me
true
what's
and
true or
not
not
true.
Let me just tell you what I would do, and you tell me if it's true or not true. Let's say I was on a court, and football, baseball, whatever the fuck, it doesn't matter. Just a court, all right. And I take a picture of an object that's on the other side of that court. I do not know the distance, and all I am given is my telescopes with really precise motors that can tell me the altitude and azimuth of wherever the fuck I'm pointing. If I know the baseline between two observation points on the other side of the court, and I take the measurements of the azimuth reading, are you telling me I cannot use those data points to figure out the distance between any one of those points and the object itself?
Is the court flat?
Sure. For this example, let's say yes.
No courts are considered flat, man. They always have to have a water runoff. So
Consider it for this example. Let's consider it for this example.
So it's flat. So you're doing basic trigonometry, right?
Yes. Alpha equals 2 times the arctan of g over 2r. Would that tell me the distance to that object? Yes or no?
I think you could be pretty accurate with that.
Not accurately. Yeah. The calculations will tell you the average close distance to that thing, but not the distance. So
okay, I'm talking to the other guy.
If you know the length of the baseline between those 2 points and the angles for those 2 points, you can't calculate the distance to the object.
Yeah, you can calculate the average distance, but it's not accurate.
No, you can calculate the distance.
Yeah, it's not accurate. You're not in a vacuum. You're not in a vacuum. You will have to use what you
are. It would be accurate enough. It would be accurate enough for our purposes.
Shut the fuck up and listen. So you will have to use that excuse that you use always when you are talking to flat earthers: refraction. So you'll have to measure the gradient of the air, something that you can't do. The gradient, vertical gradient, and the horizontal gradient to the object. The air, the density of the air, to just integrate the calculation of the refraction in your calculation. So it's just assumed. So your calculation is average. Yeah. It's not
cool.
accurate.
I'm gonna continue my conversation with the other guy before we all jump in at the same time.
Because I cornered you. Because I cornered you.
Sure. We'll go ahead. We'll go ahead and take that on. Congratulations on your W for that one. So Merlin,
just tell me, are you admitting that the calculation is not accurate as a measurement?
Do you think there's such thing as a perfect measurement?
There's
such thing as a perfect measurement?
And again,
you're talking to the room.
If I were to do all of these work, if I was to do all this work and I had very accurate telescopes that could align themselves with the azimuth, and I was able to take those measurements down, I measured the baseline and all that good shit, are you telling me that I wouldn't be able to figure out a distance to that object that I am observing?
In the hypothetical world,
Not you, my guy.
in
No,
the hypothetical world, in hypothetical reality that you are imagining now, where you are able to
Once
measure
you're done talking about that, I need you to answer.
So just listen, you are talking to a room, but not in the DMs.
Yeah, so what you're saying,
He's welcome to join in, guys, by the way. Like, dude, I don't have all the answers to this. I would just say that simply that if you're measuring over a court, and then you're measuring over vast distances, and then you incur refraction at those vast distances, then you're doing a calculation. You're not doing a measurement. What are you saying,
All right,
Necros?
cool. So basically, what you're saying is that the only way for the measurement to be considered quote unquote accurate is to get rid of all refraction whatsoever. So here is the other question I would have. The question is, how much does it impact the result?
It's a difference.
Only having one line.
No. So because here's the thing: if I'm seeing that it doesn't actually impact the final answer all that much to save your bullshit story, what am I to get from that?
Because your calculation, you've inferred a certain formula in order to get your appropriate answer, have you not?
No, that wasn't inferred. It was actually discovered. Because guess what? I didn't infer alpha equals 2 times the arctan of G over 2R. That's called trig. That's called trig, my guy. And so if I use trigonometry, that's not me inferring anything. That's me using a mathematical tool.
Did you do the refraction of those vast? Are you talking about vast distances now? I mean, I get that you're trying to bring it down to the port size, and then you're trying to extrapolate to a larger size.
We'll get to the vast distances later. Believe me, we'll get there.
Problem.
We'll get there when we get to the vast distances.
But for that, you need two angles and a distance that you know to make that calculation in the first place.
That's what he said. That's what he's doing.
I'm getting to that point, but here's the thing: you guys always want to jump to the extremes. I'm going step by step here. So let's start with the court size, then we'll go to planets and literally the solar system after that. Sound like a deal?
Yeah, but that's just if you don't have the court size, you just have a single point on the surface.
Then let's do that. Okay, cool. So since we know that at the court scale it works, are you at least comfortable to say that this works at the court scale?
Is the court scale Euclidean in nature?
Oh, for fuck's sake! It's a basketball gym. Let's say
it's Euclidean. Thank you.
All right, perfect. So you agree that on the court scale, trigonometry works, correct?
Not 100%.
No one's disagreed with that so far, man. You've asked that again. No one in this room has disagreed with you.
Yeah, there's no such thing as a completely accurate measurements whatsoever.
Yeah, even if you want to do it with a ruler, you're always going to have to
wait, let me correct him. For measurements, yeah, it can be accurate 100% because measurements are just comparison. You compare the thing that you're measuring to how many units of measure that you have. You can use cubic meter, like from your elbow to tip of your elbow to the tip of your finger. It will never change. It will still be there. It will never change. So the unit of measure is unchangeable.
Actually, that's very good. No, actually, very good. That's very good because what he said is actually going to fuck him later. Remember he said that. Remember what he just said. It's a comparison against something else, and it will never change. I want you to remember that. All right, let's go ahead and go to the planet scale. I'm going to measure the distance to Mars. Now, if I do, hang on, we remember what you said. You just fucked yourself, and now I want you to bend over with your pants down and wait for it. So here's what we do.
Hey,
The stars, the background stars,
the weird gay
the
stuff,
background stars. If I measure the where the planets are relative to the background stars from Colorado, and I do the exact same thing. I have my friend take the exact same thing using another telescope in Florida, and I see those exact same stars. And I'm making my reference based on those stars. Because you said that scale doesn't change, that means that the angles would be accurate, right?
No.
Contradiction.
So you're measuring like something in the sky versus something on the ground?
Yes. Oh,
you really need to stop with the profanity and invoking like all this domineering language that you're going for, and then laughing at that is really weird.
And put it on my channel is whoever has
you're a deplorable character.
No, that was so
you're gonna try to fuck someone in the ass or something? That's just weird, man.
Oh god, that was awesome.
My statement.
That was so fucking awesome, guys. Thank you so much for that.
My statement didn't change by what you just said because still the unit of measure. Remember what I said. The unit of measure that we use, no matter what is the unit of measure that we are using, if it is meter, if it is a cubic meter, an elbow, if it is a stick, so we can take the stick and put it forward and take the measurement. That doesn't change. What you just said, it's just calculation again.
Dude, if I'm using the distance between two stars as my unit of measure, does that not count as a unit of measure, literally by definition?
Red,
if you're using the distance between two stars?
Red, just out of curiosity, man, like on that court
where did you put your meter stock in between those two stars?
Just one sec. On that court, you can go verify your measurement, right? You can go walk over to the other side of the court and verify your measurement. Can you not?
Yeah, you could, actually.
Cool. And go do that with Mars, man. Go do that with the stuff in the sky, please. Because, I mean, you're just leaping into a different dimension as far as I'm concerned.
One of them was an 8-inch Schmidt-Castle screen. The other one was an 11-inch. They have more than enough resolution. And
a square can be a rectangle. A rectangle can't be a square. And acute triangle can be an isosceles triangle. An acute triangle does not mean an isosceles triangle.
Thank you. So what we did was in two separate locations. We looked at Mars, saw the background stars. Using the background stars, we could figure out the parallax. After we knew the scale of our image, because we were using the background stars, we then said, okay, how big does Mars look in the frame? And then once we found that measurement, its angular size, we had its angular size, we had its distance, which means we could find its actual size. That was a data point we needed to find the distance to the sun.
Yeah, I understand what you're doing there, but yeah, like it's all very relative. Like
relative to what?
You know, well, relative to three approximations, and then coming up with a final assumption about the sun and saying, "Oh, look, that's accurate."
I don't understand what you're saying here. Relative to what exactly?
Well, when you calculate an angle that's that far away, and it's a tiny little angle, right? You've got to imagine just a very tall, pointy triangle. It's a tiny little angle at the top, at the peak of the triangle, and then the base measurement is tiny as well. And so, any small deviation in regards to accuracy would have a huge impact on the result.
Well, the baseline was over 2,000 miles long. Let's make that point. So that one was not small. The angle itself was small, but
that's nothing. That's nothing in terms of the length.
True, but in human scale, it was massive. That's why it took 2.5 days to drive to Colorado. And secondly, even though the angle is really small, it was within the resolution capabilities of the telescopes that we were using at the time. Again, we're talking massive telescopes here.
To what second of a degree are these telescopes precise? It would be a good question for you to ask right now.
It would be a very good question. Does he care for the answer?
So you've got the base length right between the two places,
and then you've got
the angle. So from that, you're no.
Do you understand why it's important to know the accuracy or to be more clearly the precision that these telescopes can do, like to the second of a degree of the precision?
Yeah, I'm not disputing that. When you look through it, it's quite accurate. The gimbal's it's very good. It knows exactly where it's pointing, etc.
No, how precise do you think it is? How precise do you think it is? To what do you think it goes to?
Like a half arc second.
Does that mean anything to you?
Yes, an arc minute is like 1/60th of a degree, and then an arc second will be 1/60th of that. Talking like half, so you're like 1/7200th of a degree.
So,
am I close? What is it? Tell us the answer.
I don't know. He knows the telescope specifications. I don't.
Well, what are you asking the question for? It's not part of the conversation.
Because you're saying if you're off, if your measurement is off or it's not accurate, you're saying that his measurements are going to be off by 20-30%. How do you know that if you don't know how precise the instruments are?
No, the instruments are very accurate. I don't disagree with that.
But to be clear, it's 0.1 arc seconds per pixel. 0.1 arc seconds per pixel. That's the resolution capability that we were on the night observation. 0.1 arc seconds per pixel.
Yeah, cool. So
we had more than enough resolution to work with. So, given the fact that we had more than enough to work with, what was the problem? Was our equipment not good enough? Is that what you're saying?
What I'm saying is that when you have a bunch of different things that you're assuming, you end up with So you don't know how much the light is refracting through the atmosphere. And,
It didn't
the
matter.
big
We were
mistake.
using the background
Hang on,
stars.
let me finish. Huh?
It didn't matter because we were taking the observation from two different locations on Earth with different refraction values, and refraction wouldn't matter anyway because we were using the background stars, which don't care about refraction. Their scales are going to remain.
Sure. So what I'm saying is that you're assuming that the Earth is curved, so your angle there could be off by, I don't know, 10%, 20%. And the second thing is, like you said, you were using the chord measurement, so that's wrong, right? So rather than using the actual distance, and right, so well, anyway, wrong in my opinion. So you've got two factors there, and then when you're looking at the distance to it, that's one a calculation that could be off by a factor of 50% depending on what you're doing there. And these are isosceles triangles, so the error stacks up very quickly.
What's the difference between the arc measurement of that has like what's the arc measurement that would be different from the chord measurement? Like, what's the difference of a 3959 sphere if you have a chord distance of 2,000 miles versus what would be the arc measurement? The radius of 3959.
2100.
I think what he's trying to say here is that there were two assumptions being made. The first one was based on the chord distance, and the second one was based on the curvature / size of the Earth. I'm not going to fault you for those two things because I imagine you just entered into this conversation and you probably haven't seen the video that I made that I posted like 3 fucking years ago. But the fact is that at the beginning of the video, we've figured out the size of the Earth. That was part of our calculation.
But he thinks like you're using the so you're using the chord measurement for the base of your triangle, which would be accurate. But he's saying like, well, you're using an arc measurement translated to a chord. I'm saying like, if he thinks the arc measurement's the flat measurement, what's the difference between what he thinks the base is versus what actually you're using for the base? So like the arc measurement from Florida to Colorado, I'm assuming because it's only going to be about like 15 degrees, like of the how much are we doing? What's the difference in the longitude?
Well, I drove like 2,000 miles, and there's you have to travel 69 miles per degree of change, so it would have been quite extreme. But keep this in mind: one, we took that into account, and two, when doing the chord length, that's again just basic trig. You can figure out the chord length literally just by knowing.
He's saying this. I get it. Like I know what you're saying, but like he's saying there's an error in the measurement. So I'm just trying to figure out. Like I feel like the difference would be like 25, like maybe like what 2,400 miles, like. With the difference, I can't imagine like it's that much of a difference from the arc. I'm trying to do it in my head right now, but I just can't.
I think you should answer that question though. So let me ask you, good sir, just directly. Where do you believe where any error was introduced into my measurements? You mentioned the chord, you mentioned the size of Earth or the curve of the Earth. Both are synonymous in this context. But what do you think? Where do you think the error was introduced?
Well, this is a potential error, right? If we are if we're living on the floor of the universe, then the angles you're off by, I don't know, 10, 15 degrees. Then you talk, and then the chord length, right? Obviously, and so when you use those assumed differences in the angle because of the curvature of the Earth, you're making the distance to it different, right? So by that, then you could be off by a lot when you go to say what the size of it is.
Yeah, if you were to add a different value into your calculations, then yes, you would be off. But the deal is that we figured out the size of the Earth before we did any of that. Step one in this process, literally the first thing we did in my video was figure out the radius of the Earth. That had to be the first step. If we didn't do that,
how long did you drill for?
What's that?
How long did you drill for? Did you use one of those new microwave drills?
No, we didn't use any drills. We used telescopes in the North Celestial Pole. So if you are on the
figure
surface,
out the radius of a sphere, you don't need to drill to the center of it and then measure the radius. That's not the only way to measure a radius of a sphere. You have formulas that to determine a radius, and we can figure out the other variables to calculate the radius. That's how math works.
Well, I think
let me explain the methodology real quick. If you are at a particular location and you measure the altitude, that is the angular altitude of the North Celestial Pole, which is possible with modern day telescopes, you take down a measurement. You then go either directly north or directly south. It doesn't matter. It just has to be either directly north or directly south. So let's say you go directly south, which we did for our observation. You go directly south by some distance. You write down that distance. You say, okay, I know I traveled this far. Then I see the change in the altitude of the North Celestial Pole. I write down that difference. I go, okay, I observed this amount of difference, this shift over this distance. What does that mean in terms of the radius of the Earth? And you can easily figure out a value. You don't need to drill to the core of the fucking Earth, my guy.
So what he would do is like, so for that would be a very small sample of how we came up with the ellipsoid, like the Clarkson ellipsoid for surveying. And now that ellipsoid is really only good for North America. It's not really good for the opposite side of the Earth, which is now why we have a global ellipsoid. But anyway, that's just a little surveying knowledge.
Yep, and for those of you who are wondering, we were accurate to within 2 kilometers of the current accepted value. So, nice.
We did the same in the ATSMI Astronomy Club, going from 62 degrees to past 69 degrees north. And we ended up, I can't remember, 111 something. It wasn't spot on, but it wasn't too bad.
No, it wasn't too bad for us either. So after we made that measurement, that was just step 1. Then we verified Kepler's third law. Then we figured out the size of Mars. And then using all of these different data points, we were able to figure out a distance to the sun. And if I remember correctly, I'm going off the top of my head here because it was years, I think we were accurate to within 1.2%. Which is
considering you're using like 5 measurements off of like from the original. Yeah, that's pretty good.
It was like 1.2% is how far we were into the current accepted value. Not bad for something that's supposedly impossible. So that's why we made the video and posted it on my YouTube channel. So it's there if you guys want to take a look at it. But modern day telescopes have the capability of making these measurements, so that's why I got them. So if you were wondering, like, was it within the resolution capability of my telescope? Oh, yes, it was. It was totally within the resolution capability of my telescope. I'd be willing to do that observation again if any of y'all would love to join me for an outing underneath the clear night sky.
These this arc seconds, right?
0.1 arc
based
seconds
on
per
the
pixel.
distance.
Well, the
No,
resolution is...
But that, yeah, let me finish what I was saying. So that the size, right, is a calculation from the angular size. When you think about the Earth being a sphere, you're putting an error in the angle, so it could potentially be much closer, and then hence be much smaller.
You don't measure angular size from 2 different vantage points. You measure angular size from 1 vantage point.
I know. You've got a distance that you've calculated from parallax, which I don't think is accurate.
Well, that's great that you think that.
I wonder how your results are compared to, let's say, distance measured by VLBI, which has, 0.1 milliarc second accuracy?
Something like that. I can only tell you that we were accuracy to what the current accepted value is, and it was definitely around like 1%. So we were within 1% of the current accepted value.
And he's not using like the standard measurements of what Mars is or what the Earth is. I mean, at least that's what it seems like you're telling me. You're saying like based off of your 98% accurate measurement of the shape of the Earth or the radius of the Earth, you determine like the shape of the distance from Colorado to wherever you traveled, right? I'm assuming like these are all measurements that you did, except for I guess the Colorado to Florida one. That I guess
No,
you just used the standard.
No, we could easily do that as well. Yes, every measurement that was utilized was via our own work, except for 2 data points, and that was simply historical data. But I want to make this clear: the data that we utilized was also from amateur astronomers, and it was to measure their angular sizes of Mars. So, how big did Mars look to them at this particular date? How big did Mars look to this other guy at that particular date? That's the only historical data we use. But the size of the Earth, the distance to Colorado, the distance of the core length, the parallax of Mars, the actual size of Mars, all of that was through our own work.
Very impressive.
Thank you. I appreciate it. So when we utilized, or I should say, when we went about going through this project from start to finish, we wanted also to verify Kepler's third law, and that also required our size of the Earth to be accurate in order for us to get a result that would even remotely match reality. And we were accurate to 99.28%, if I remember correctly, using ground-based observations. That is fucking amazing. That was fucking amazing, in my opinion. 99.28%? Fuck yes.
It's really impressive.
Yeah. So
and not at least all the efforts you guys put in to do it.
yeah, driving to Colorado was a pain in the dick. I'm not gonna lie. That actually sucked. That was a horrible drive.
Yeah, but Colorado's beautiful.
Colorado is fucking gorgeous, but getting all the way back to Florida, that was a pain.
See the prairie dogs on the side of the highway?
I mean, I saw there was a lot of Kansas, and when I thought I got to the end of Kansas, there were just more Kansas. I couldn't wait for Kansas to be over, but it just never ended. There was just so much Kansas. It was absolutely horrible.
What if one rented several of these online telescopes and used that as to try to measure the shape of the Earth? Could we do that?
Yeah, you could. You could
Still
rent
doing a
time
calculation.
A few hundred miles.
All right. The only reason why I'm sorry, I'm about to go get ready for work. That's why it's in a hurry. But you really think that like 9 to 60 pixels? So like if one pixel changed from like blue to green, a pixel we're talking about, right? That's enough to make a determination if it's if like the atmosphere has like mostly consists of oxygen or or like how can you make a determination like that, like, or anybody for that matter, just by like a pixel changing from like blue to green when like a YouTube video from back in the day has 240 pixels?
I'm going to just say it's a lot more complicated than what you're making it out to be. And what I would recommend you do is you read the scientific literature to discover why they're so confident in their findings. Now, how much is the shift? I doubt it's as extreme as going from solid blue to solid green. I'm sure there's some variability within it, but keep in mind that when they're observing these exoplanets, they're doing so for an extended period of time. And so they can get a lot of data during that extended period of time. You know, they're observing it for a very, very long time. I'm assuming they're observing them for days at a time. with all this data, they crunch the numbers and they look at any sort of variability and they say, okay, given what we have here, what is the most likely scenario? What is the most likely condition on that exoplanet that results in our camera sensor behaving in this particular way? And then they simply post their findings. Now, could follow-up observations refute that or add to it or refine the findings? Sure, better telescopes are already slated to launch, but as of right now, that is how they're doing it. They seem confident, but more observation, they said, are needed. They'll even tell you that.
Yeah, I was informed by someone who's actually in the field to that confirmed that yes, it is only like 9 to 60 pixels that they have to work with. But like, how is that even like? That blows my mind that someone can make a determination off of that many pixels, and then you see like the CGI rendition of what an exoplanet's supposed to be like, supposed to look like, and they have like
that's an illustration.
Yeah, it's crazy. I think it's just complete deception for the public.
No, they're not trying to pass off those rendered videos as real life images. That's why they are very, very anal about making that known on the clip itself. This is a CGI rendering, or this is an artist's interpretation. They make that very clear. They're not trying to fool you with that.
Well, I mean, if you just type in exoplanets, like if I'm just an average Joe and I hear about like livable planets in the universe and I type in exoplanets that are habitable, I don't get the actual rendition or like even a side by side or anything like that. I get these perfectly spherical CGI renditions with beautiful colors and swirling patterns of cloud formations and, like you said, surface features and etc.
Because you're looking up articles. You're looking up
renditions. You just said they were renditions.
No.
Yeah,
All I did was typed in habitable exoplanets. I'm just an average Joe. I'm just trying to figure out like.
Then here's what you would do in that case. You would not be an average Joe and type in after that scientific papers or scientific publications, and you would read that. You're not average. You are incredibly smart and intelligent. I mean, after all, you're in this space right here, right now, so you must be a fucking genius. So you know that you can search for the scientific papers that have all the information embedded within it that will illustrate to you why they're confident in their findings.
You don't think that's like a form of deception, though? Like
No, they're not hiding it from you. Because you don't know how to search for a scientific paper is not a failing on their part, my guy.
I said, okay, all right. Well, I mean, because this is the difference, and I was just curious to see your thoughts on it, but that's okay. I appreciate your time, but I'm just gonna post this because this is what pops up originally. Potential habitable exoplanets, right? But if I type in exoplanets, real images, someone did a nice collage from the Exoplanets channel. This is what it actually looks like.
Habitable for what? For humans?
I think they're saying it's within the Goldilocks zone. Basically, it's at a certain distance away from its star that liquid water could theoretically exist on its surface. I think that's what they mean by habitable, is that you can have liquid water on it. Because if the situation is such that liquid water cannot exist on its surface, then life as we know it cannot exist on that particular planet, because water is literally the thing that's needed. So no water, no life as we know it.
But logically speaking, Reds, you gotta admit, like, making a determination through spectroscopy with this amount of resolution is bonkers.
No, I say it's within the capability of what they're trying to discover. Surface features, yeah, they don't have enough resolution for them. But they're not talking about surface features. They're not saying, hey, on this side of the planet there's a canyon. They're not saying that. They're saying, hey, given the light that's coming off of this planet, which is detectable, we can make this particular determination on this particular subject. That's not an all-encompassing picture of the planet itself. There's still plenty of things that they don't know about it, and they'll freely tell you that. They'll say, hey, even though we're getting, measurements of the atmosphere, we're not telling you that it has a mountain here or a canyon there, or if it has, civilization on it. They're not saying that. They're not saying any of that.
Requires a lot of faith. A lot of faith, man.
I don't think it does. I don't think it does. If you are limiting your announcement to only the thing that you are detecting, that requires no faith at all. That's just reading the data.
I think we
it's a
need to get
lot of faith
yeah.
in determining, like, hey, this possibly could be a habitable, livable planet, and to make the fate of humanity's, or to make the decision on like humanity, like that would be faith. Like you would have to be taking a leap of faith, right? Because to make a determination off of 7 pixels is nuts.
They're not making a determination of humanity by reading the atmospheres of exoplanets. They're not saying, oh, we should like totally go there if Earth decides to, implode on itself. They're not saying that at all. And I believe you would know that if you had read it, because they're not saying, because of our findings, we should totally go there and build a Starbucks. They're not saying that in any of the scientific papers.
And I think there's a bit more details in it as well. I mean, you mentioned spectroscopy, but I think they have some sort of methods to estimate the surface temperature and so on and so forth.
Yeah, they can make all sorts of estimations. They're saying, hey, we made these measurements and it points to this particular thing being the case. So be it. I'm not aware of what they're doing it. I'm not even sure if this 90 pixel thing is even accurate. They might have a different instrument on board capable of making more precise measurements than a camera sensor. That's fine. I haven't read the paper, but I do know that the paper exists. That's how these publications are getting this information to begin with. But the one thing I do know is that publications often get shit wrong because their goal is not to be scientifically accurate. Their goal is to write a interesting enough story so they can sell subscriptions. That's how they make their money, which is why it's always important to go to the source.
Oh, I've seen that quite a few times over the years, that papers and other media is making some sort of magic, great news about something. And you go and look up the actual paper, and you see that the journalist who's been writing this is completely wrong or misunderstand it completely. So it is really important to go to the source.
Yep.
So the science journalists can't get it right?
Journalists often fuck up a lot. Yes, that can
so
be
scientists.
No,
or
we're
use
talking about
catchy headlines that people think mean something actually matters. Like the headline matters, not what the body of the article says.
Yeah, they'll say some sensationalist headline like I don't know. I'm just going to pull a random headline out of my ass. It doesn't exist. But
Prove it wrong by measurements of deep space, of early galaxies forming.
They'll be like, we believe that Cthulhu may be inside of this galaxy. And so the headline will start with something like that, some horse shit like that. But when you read the actual paper, it says, no, there's just a particular structure that I guess kind of looks like, if you squint really hard, looking like Cthulhu. Like they're not saying it was actually Cthulhu. Yeah, that's just a stupid example. I'm just pulling out my ass here, but
why is it not then that the scientists come out and say that, well, I mean, these guys are misspeaking, they're misappropriating the information? I mean, are they just allowing this because it doesn't really matter, or
they do?
They
do.
Have
you not been on Twitter? They constantly
no, I don't really go on Twitter.
They constantly call these motherfuckers out. I mean, it's like I remember
and so they're ineffective though. So these people of authority who are calling these people out and have no efficacy in actually
they don't have that much authority.
The signal. Well,
yeah,
you're proving they don't have that much authority.
Then your science doesn't have any authority.
You're proving that they don't have that much authority. You're proving it.
You're
right
proving
now.
it. Actually, they don't even have authority.
No,
that's what
you're proving it right now. And even though they're speaking out and saying that, like, what these people are saying are not true, they don't have enough authority to actually sway anyone.
So the guy that's like the Elon Musk guy, right? The guy that's going to take us to Mars, essentially has not got enough authority on his own channel to like basically quash this.
Yeah, but here's
Or is
the
it just
thing.
being permissible?
Have him figure out the driverless cars first, and then maybe he can get us to Mars.
Yeah, he's going to have to figure that problem out first. But also, to be very, very clear, only
another 100 years.
scientists out there. Only a few scientists out there have what I would call star power. You know, you hate one of them with a fiery fucking passion, Neil deGrasse Tyson. You know, that kind of guy.
They love him.
Yeah. Oh, they love to hate him. Let's put it that way.
You guys hate him. You guys hate him as well.
So
from what I've heard,
it's an example, my guy. Let me finish my point. So
yeah, your example is the fact that you brought up a person that you also hate.
Someone with the scientific backing, like with a PhD or someone who genuinely knows their shit, usually doesn't come prepackaged with star power. A lot of people don't care about being internet celebrities. They care about making discoveries in the lab or behind the eyepiece of a telescope. That's where they're going to focus their efforts on, not being, catchy on the internet. That's why you have assholes like me that will talk about shit and
so you
dicks.
base everything on the angle in the sky.
Reds, which one are you, dude? Like, it's either
Come on,
or.
you guys,
Apparently, it's either or. You got two.
Go one at a
you got
time.
2 lanes that you can go down. Which one
Go
are you?
one, just let him finish. Just let him finish his point, then rebut it.
Yes, please, absolutely. So let me go ahead. Before you give me the two lanes, Risque, let me tell you the lane I'm driving down first, and then you can get me the fork in the road. So, as I was saying, these scientists are not going to have star power just naturally. Their job is to either be in the lab or be behind the eyepiece of a telescope, writing scientific papers, and basically informing the broader scientific community, the communities of their discoveries. Now, journalists, they fall into the trap of Brandolini's law. And sometimes there's a lot of horseshit that goes out, and these guys, which are busy doing other things, don't have the time to dedicate to making their own newscast or go on interviews or whatever. They'll make a quick post on Twitter and call it a day and be like, hey, if any of you guys are reading this story and you see my paper, just know I do not support it. I'm going to get back to work now. I don't see how that's a mark against them. It means they're busy. So what's the 2 lanes you need me to go down?
Well, which one are you?
Repeat the two lanes that you were talking about.
They're your lanes that you provided, man. So either you're part of the communications or you're a part of the observations, let's say.
Are those things mutually exclusive? I just said that while it is
your
possible
articulation actually implied that. Yeah.
Okay, let me be very, very clear then, because either you misunderstood me or maybe I wasn't clear. I'll take the blame on that. But let's say this. Not every scientist is going to have quote-unquote star power. That's what I said originally.
What is star power? Describe star power to me. How does one become like a star?
You don't know what fucking like a celebrity status is, my guy? Don't give me that shit.
He just means fame. He's like how famous someone is.
I'm aware he means fame, but like, why is it the system that's such that these guys who do the work cannot ascertain the star power, and apparently, the people that talk bullshit do ascertain the star power.
The capability of even wanting that shit in the beginning. And you have to be very good in front of a camera. You have to be good at speaking. Some people can be very, very smart, but stutter like a motherfucker and not be able to get 2 sentences. Some people are shy behind the camera. Some people don't like public speaking events and would rather be alone in their labs doing the fucking work and putting their thoughts to paper. Are you surprised that
and what you speak for them?
Complex like this?
So then you speak for them? So they are allowing for this, like speaking for them as a consequence?
Some people, guess what? They don't have to allow it. I can read their paper and I can tell you what they read, and they would be perfectly okay with that. What they wouldn't be okay with is people misrepresenting their work. And let's say I misrepresented somebody's work. If I misrepresented somebody's work and I got called out for it, either by the person who published the paper or the team that was working with the original principal investigator who was working on the paper, I would apologize and I would correct myself. But the problem is that
what's the closest you've come to that?
but with publications like, I don't know, the New York Times, the Washington Post, what they'll usually do is they'll relegate it to a footnote at the very bottom of the article because they don't want to sacrifice their subscriber count.
What's the closest you've come to challenging the paradigm? Let's say
the closest I've come to challenging the paradigm, I would say when I measured the altitude, size, and speed of the International Space Station, when I measured the distance to Mars, and when I measured the distance to the Sun. Each one of those was a challenge, because if it was correct, then they had no reason to fear me looking into it myself. And there was a chance that I might find something that kind of fucks up everything. I just didn't find it.
Did you find anything? Okay, so for the ISS, what did you find something that didn't match the numbers they provided?
No, for the ISS, I wanted to know, one, what was its orbital velocity? Was it even traveling at orbital velocity, I should say? Two,
Okay.
what was the size of the space station? And three, what was the altitude of the space station? Because if the nameless, faceless they are correct that the International Space Station is in space, then it should be, well, around 400 kilometers in altitude, traveling over 7 kilometers per second, and it has to be the size of a football field. So when I went out and checked it, that was a challenge. I was like, okay, I'm going to double check your work. That's a challenge. So I went out.
I asked you when you challenged the situation, not when you were challenged by the situation, when you actually challenged the situation as you actually
provided.
That is
challenging the situation. Every time you put the situation under a microscope for scrutiny, that is challenging it.
No, that's
by
fair,
definition.
Riksky. That's fair because, like, if you're challenging the numbers that they provide about the ISS, which, there have been amateurs that have, right? I don't know if there's people on board, but the ISS, the dimensions, its speed, you can see that by like contrasting it with like the moon, right? In terms of like its angular diameter.
We did use that method. You are correct. We also use the background stars, so not using the moon. So we use both methodologies.
He used the standardized methodology in order to determine it. So he didn't challenge the methodology at all. He didn't bring anything new to the table. He's just basically he used the methodology that they approached it from that should be appropriate, and it just matched up.
So you're saying that in order for me to verify everything, I literally have to invent trigonometry on my own? Sure. Let me start let me start with Pythagoras, and we'll go from there. Right? No, absolutely not. Since I know that the law of perspective works, I don't need to invent my own law of perspective mathematics. That also works. The thing that works literally by definition. I don't need to invent I don't need to reinvent calculus to use calculus.
You've reinvented my question or my query to you, but Biasicles, what was up?
I was just going to say, I mean, even with the moon as like using it as like a background contrast, right? Like the moon changes size all the time, but it's not significant enough to like really change your numbers there. But essentially they say it's 108 meters wide or something like that.
We got it to the size of we got it to the size of a football field. I believe our measurements had it at 105. The altitude was 412.4 kilometers. Its velocity was I don't remember the exact number, 7 point something kilometers per second.
Altitude, I can't, I don't really know if you can really make a determination, but I guess you can if you just know like the size, the speed, and then you would have to, based off their numbers, but like the actual size and speed you can do. I don't know about altitude, but
you can do altitude.
If you observe the International Space Station at the horizon versus like directly above you, there should be a like proportional size change or not?
Oh yeah, there's definitely going to be a size change, but we didn't do that. We waited for the ISS to be almost directly overhead.
There you go.
Well, that's what you have to do to actually, least amount of refraction, least amount of angular size change of the moon, right?
And also, there's a different problem. If you were to wait for the ISS to be close to the horizon, you would actually be looking at the ISS kind of edge on down the truss rather than looking at the width of the truss. In order
That's
to
what I
find
want to see. That's
in
what I
order
want to see right there.
in order to find the width of the truss, we had to be looking at it from an angle in which we would be able to see the width in full. So that's why we waited for that particular opportunity
The ideal opportunity.
to see the width of the truss. Yes.
I was going to
Yeah,
say
to justify the interpretation. Yeah.
you can also back out the velocity by analyzing the Doppler shift of the unencrypted data coming down. So you can do optical observations. You can also do RF observations to back out kinematics.
You can do. I've heard of amateur radio operators, even talking to astronauts on the ISS using their own antenna, which is pretty fucking cool, honestly. And basically,
Yeah, the ISS is in the sky. We can all see it, but there's no fucking way there's people up there, you guys. There's no way, dude.
Well, let me give you evidence to the contrary. Now, let me just see what you think of this. So I was able to capture the International Space Station at 3 different points, or 2 different points, and then there was a third point in the middle. I saw the International Space Station with no Dragon spacecraft attached to it. Then, after the launch of the Dragon spacecraft, I saw the Dragon spacecraft docked to the station. That's point 1. Point 2 is that Astronomy Live has a video of that rocket on the launch pad, and it's 2 hours of uncut footage of astronauts boarding that spacecraft.
Wait, you actually have a correlative before and after picture of the ISS when it's been docked by the Dragon, and then you also have a corresponding timestamp of like, hey, the astronauts are going back and forth in the ISS now, live on YouTube.
Let me be clear. I have a video of the ISS with no Dragon docked to the station. It's an empty parking spot. Then we have a video of the launch of a Dragon with astronauts on board. And we have video showing astronauts boarding that particular spacecraft. Then at a later date, I captured the space station again, only this time the Dragon is docked to the station. So no
Later
Dragon.
date, not the same
Yeah,
date. It's like how long were they up there for?
6 months. And I believe these observations were made a week and a half apart. So you have no Dragon, the launch of the Dragon, and then the Dragon docked to the station. I have those 3 separate observations. So
if you don't mind, you mind posting those things? I'm curious.
It would be good. Yeah, that'd be interesting for sure.
I can send to you. I believe I also posted.
So when
on
you take
Twitter,
these photos, this is like midnight that you're taking these 2 photos separate. Like they're 2 photos 1 week apart by the sounds of it, right?
Yeah, a week and a half ish, and that is a very good question.
That's
so
all right.
I was taking these photos because I wanted to capture a transit of the space station using the moon. We weren't getting any measurements on this particular one. I just wanted it because it was fucking awesome. But the first transit that occurred, there was no Dragon docked to the spacecraft. The spot where the Dragon would be was empty. I then drove to Cape Canaveral to see the launch of the Crew Dragon. So I filmed that launch. That launch is on my YouTube channel. Then a few days later, after that, I captured the space station again going across the moon. Only this time the Dragon was docked. So we had a before, a launch, and then an after.
And what's the backdrop? Is this like the backing of space? How are you seeing the silhouette? Like
the moon was the backdrop.
I mean, I guess we'll find out.
You managed to So you managed to line up yourself with the moon perfectly. The ISS transiting the moon in 2 different locations, a week and a half apart.
Yeah, you can do that, dude. There's an ISS tracker.
That's pretty wild. Like you got to run around.
Yep, I have a car.
Presumably,
I have a car.
No doubt, you could do that. That's just like you got to go find the particular location. Like you got to be pretty accurate, no?
Yes, you do have to find the particular location, and that's why I had to drive all over Florida in order to get that shot. But I did get it.
Dude, that's the best.
How many times does the ISS orbit the Earth
that's a cool
in a day? How quickly does the ISS orbit the Earth?
Every 90 minutes, supposedly.
Once every
90
90
minutes.
roughly.
Once every 90 minutes. So I mean, like,
Yeah, but
that's
it's
kind of
rotating like the moon is rotating like, and it would stay like for a month. It's shifting up and down in its position in the sky, right? And then like the ISS is also like performing its own theatrics with its what is it, flower of life formation. So you got to line those things up.
flower of life.
I don't know what that means.
If you
but
look at it, if you just look at if you basically do a transformation of the ISS transition across the globe and you like make it an AE map, it basically starts forming a flower of life.
what I'm saying is that there's actually a website that I was using. It's called transitfinder.com. And what you do is, or you can just go to Google and type in Transit Finder. And what you do is you type in your location, and then you type in a date range. I usually go a month out, and then you hit search. And what it will do is it will list on the map where you need to be standing and the time you need to be standing there in order to see the transit occur. I'm dead serious. Go ahead, try it out. Try it out right fucking now and see
No,
for yourself.
I've got no doubt that the calculations are performable. I just think it's pretty amazing. Like you're basically like just chasing this major observation all around the United States. It's rather impressive. I'll give you that, man. Tip of the hat.
It's like people who chase eclipses, bro. They know when it's going to happen because it's cyclical. Just like the ISS is cyclical. That's why I don't think there's people up there. I think the ISS is actually something that's been around for a while in terms of like a entity. I don't know.
In the chat right now, I just posted an image for you.
My only issue with the entity claim, Biasticles, is the silhouette of the ISS seems to resemble that of solar panels. So not sure what to make of it. It certainly looks mechanical in its sort of structure. Although I would acknowledge, I think Jeremy brought this forward, was these shooting stars that we see, or satellites, they could have been around for a lot longer.
Well,
Reg, you
different.
posted that in the live stream voice chat, not the outside chat, the live stream text chat.
Yeah, in the live stream text chat, I posted an image that I took of the space station.
That's the internal one, not the external one.
Yes. This is another picture I took of the space station, more close up with my Celestron telescope, ASI 174 mm.
Am I wrong in saying, Terry, like basically you're saying that it's better to actually post to the text chat, Red? I think that's what he's sort of implying.
Yeah, that's where people see it easier in the outside chat.
Oh,
so when is the ISS actually going to be decommissioned, as rumored?
I don't know, somewhere in the 2030s. Last I've heard, I'm not sure.
I've copied and pasted a couple anyway. I took a screenshot of Red's one of the transit of the space station, the first image I posted.
I just don't think there's people on board, man. It just doesn't make any sense.
Well,
doesn't make any sense because there's so many.
Story. That's why I brought up my observation, because I wanted to hear what you thought of that. Now, you may not fully believe that there's people on it, and that's fine. But at the very least, does that evidence at least suggest that such a thing is actually the case?
Where are you posting?
I apparently put it in the wrong.
It's in the side chat.
I put it in live stream one text.
Yeah, that was my bad. I apologize.
No, I see that. I'm saying, where's the before and after?
Oh, I'm gonna get that to you. It's on my Twitter somewhere, but I have to send it to you. So what I'm gonna do is I'll send you a DM.
Can you hear my reasoning though, real quick? Because you have claims that you have people staying aboard the ISS. You have the Russians, the Americans, Australians, Europeans, etc. People going back and forth on the ISS. Not to mention, it's been up there for how long now? Over 20 years?
Over 20 years, easy.
Yeah, over 20 years, and it's flying through, space at 17,500 miles per hour or something like that.
Mm-hmm.
Right, and then you have no reports of any incidences really about like hitting certain micrometeorites or space debris, or wouldn't there be like routine missions of like having to, resupply or
That's what
doing
progress
maintenance
vehicles are
work
for.
or like any
That's what
incidents on board,
That's what spacewalks are for. So literally,
You haven't
as you
even
were
got
going
footage
down
of
all
it
those,
being assembled.
at least for all of those things, it's like resupply. Yeah, those are called progress vehicles. Those are launched from Russia, or Crew Dragon is what's launched from the United States to resupply the International Space Station. Both of those are resupply missions. Then you're talking about like periodic reboosts. Yes, that's the progress vehicle that's launched from Russia. Cargo is also done by the orbital ATK spacecraft launched on the Atlas, if I remember correctly. So the Atlas also resupplies the International Space Station. That is a disposable
but hull
resupply
integrity.
vessel. And there's also the Dream Chaser, which is a new space plane-based type of resupply vessel that's currently in development.
Right. Okay. So you have an answer for everything, but the hull integrity factor, like it's flying around Earth supposedly, and it's going that fast at those speeds. You would think that there would be some wear and tear.
There is.
There are.
That's why they do the necessary repairs whenever they do spacewalks. Spacewalks aren't done just for the fun of it. Sometimes it's for upgrades. Sometimes it's for repairs. Like
I want to see a
like what they're
micrometeor
doing.
smashing into a solar panel, like right off the shard, like full on Hollywood Danger style. Why haven't we seen that shit?
Yeah, I think they had to fix a leak once due to micrometeorites, and they are
use bubble
impacted
gum?
by them.
Yeah,
I don't know what
solar
they used.
panels are flexible. Solar panels aren't made of glass like they are here on Earth, or they don't have a glass protectant because there's no need for it. That's why if you look at my image that I posted, that's why if you look at the image that I posted of the space station that I took myself, you can see extra solar panels. Those are meant to supplement or even full on replace the older solar panels that are already on there. Those are called IROSA.
IROSA solar panel?
IROSA solar panel. They're a new rollable solar panel meant to supplement, if not completely replace, the bigger solar panels that are already on the station. That's because they've degraded,
Got a photograph of that one?
they've been basically fucked around for the last 20 plus years, and so they have new solar panels to compensate. That's why I posted that image, so you can see that. That's my image.
Do they just roll the the new solar panels over the top of the old ones?
Yep, that's what you can see there. So in the image, if you you might have to pinch to zoom to actually see it, but look at the solar panel that's the furthest to the right. You see how it kind of sticks out, kind of in a very wide V shape.
Yeah, how do they adhere it to the surface of the old solar panel?
It's not adhered to the surface; it's at the pivot point. So what they do is that they anchor it to the same anchor point that the original solar panels are at. Either they use a particular bracket to adapt it to what's already there, or maybe there was a fixture already on the space station for it. I don't know, but either one is feasible. And then all they have to do is plug into the mains the same as the solar panels that are already there. And those are meant to supplement the solar panels that were there for 20 years.
What's the image past the hour? Like, can you give me is it just the most recent one?
That's that image I took in September 4th, 2025, and I believe it was at 5:30 a.m. So that was 5:30 in the morning.
And so what, you think that's them like rolling out the new solar panels, like the extra fuzziness or something?
No, the solar panels were already rolled out long before I took this image.
Okay, can you restate how they adhered the new solar panel? So they rolled out literally the new solar panels over the top of the old ones? They just left them lying underneath as you would? Like you just have that structure that you can roll them out on?
They're rollable solar panels. So IROSA is a replacement solar panel that can be rolled out into position. So what you do is you anchor it to a particular spot on the space station. I guess you can anchor it
How do you
to
anchor
the
it?
truss structure, and then
How are you anchoring it?
I don't know, with brackets. So then what you do is that you activate the panels. There's a rolling mechanism on a spine that extends outward, and as the spine extends outward, it rolls the panels out.
I've never seen footage of this. That's rather interesting. So,
I mean,
okay, I principally understand the mechanics of what you're referring to. How do they actually? So they anchor it at the top, presumably using screws, bolts, brackets, like something.
Somehow, some way, it's the concept of anchoring something to something else is, I think, well established.
Well, I mean, no, it's kind of interesting. Like, how are you going to pin it to the solar panels, and presumably you don't have any air to worry about. So, I mean, do you need to create contact points across the surface there? You, glue it down with some silicon, or have you got like screw points as it rolls out?
I'm sure some points exist along the way, but I doubt that it was as big of an engineering challenge as you're probably thinking it was.
I mean, you had this sophisticated piston thing that rolled itself out or something, and it's laid itself across the existing solar panels.
Well, it didn't.
My question to you is in my understanding of engineering, mechanically connecting something to something else is actually, it's probably one of the most important things that needs to be looked after, and you have got not a description of it.
You can Google it. You can actually Google it. It's on ISS solar panel renewal. You can just Google it if you want to look at it, rather than relying on someone else.
He's telling us the story.
No, you're asking. You're asking actually without notice. You're trying to get a gotcha.
He's telling us the story. Now I'm asking questions about it.
Okay, here's the thing. Here's the thing about your questions, though. I wasn't involved in engineering installation, so you asking me about these things is kind of weird. I'm just letting you know that they exist because I took a picture of it.
So your picture is discernibly different to a previous picture, because I mean you haven't got a before and after of this particular one, do you? With the dragon connection.
No, that's a different thing. In that particular image, you can actually see the dragon is already docked. No, I haven't posted that before now. Yeah, because I need to find it in my archives on Twitter. And quite frankly, I haven't been on Twitter in quite a while, and I'm on my phone. But don't worry, I promise you.
I don't pay attention to Twitter either, dude.
Yeah, Twitter is kind of a dumpster fire right now, so I don't go there often. But
I'm just kept.
Yes, so I will be sending it. Rest assured, I will be sending it. But
dude, I think Yasikles and I at least would much appreciate that. I think that's a very interesting piece of. I'm surprised I haven't come across it yet or heard it talked about.
That's such things. So when it comes to the evidence of that is only to show human occupation. But I am curious as to one thing. I know I haven't shown that particular piece of evidence yet, so don't at me on that. But let's just assume, for the sake of argument, that I was able to show that I do have that piece of evidence. What would you think of it?
What, you've got a photograph? I mean, dude, I don't know. It's really unfortunate. I would love to be able to wholly trust that sort of stuff, but in the age that we are in now, with the ability to reproduce stuff, yeah, we're kind of cooked, I think.
So
there's basically going forward in conversation. Yeah, I don't mean to be rude, but that's just the most reasonable situation, isn't it? Because I could just be another guy online. I mean, dude, I respect your hustle. It seems to you're hustling. I'll give you that. But yeah, basically people are just going to look at this stuff and say, I mean, I'll still look at it, man. I think it's an interesting sort of conversational piece. We can talk about it, but yeah,
yeah, but if you're just going to dismiss it as AI generated slop, then what would be the point?
Yeah, but dude, that's the age we live in. That's the circumstances, that's the technology and where it's at, and authenticating things in this paradigm is very difficult, right?
That didn't stop anything before. Before it was AI, it was everything CGI. Now we have AI that makes the situation easier, I will accept, but all of this evidence was posted before AI was even a thing.
I'll take that into consideration for sure. If you say it's before, when did AI become a thing?
Really take off?
What? Post-pandemic, 2022.
Yeah, so if I'm posting images from 2020, 2019, 2018, something like that, that would be before this AI slopification that we're forced to live through. Is that correct?
Red. Yeah, technically it might be more
AI
interesting.
since the 50s. Obviously,
that is true. Also, yeah, but if Red's Rhetoric's has got a timestamp on a Twitter thing that he did, I mean, I don't know. I'm willing to consider it more, and not just dismiss it as AI slop. And I'll say, okay, well, we can actually have a conversation about it.
All right. How about this? What if I posted on Twitter before Grok was a thing, when Twitter was still called Twitter?
It's pretty funny that we still call it Twitter. What did Eli? He wanted to make X a thing. You can't make X a thing.
No. I'm still calling it Twitter. So, but given that I posted this on Twitter when Twitter was still called Twitter and Grok didn't exist, that would lean in the direction that it's not AI slop, right?
Yeah, I certainly wouldn't, like, as I said before, I respect your hustle and
our heads against each other and, you know, ripping each other's faces off. No, they're actually really, really nice. It's a great
I've
crowd.
been to a
You
metal
should be a part
concert,
of
bro.
it.
I know what's going on.
You should go to one of my concerts, is what I'm saying. And you'll actually love the people that you hang out with. You'll make some new friends.
Yeah, I mean, they got problems too, right?
If their problem is being friendly, then yeah, they got 99 problems.
Yeah.
Met a lot of great people at the heavy metal concerts, especially like when I saw Parkway Drive and I Prevail. Oh, so fucking good. And it's also great when they add pyrotechnics. Just imagine this: you're the drummer of a band. It's like, okay, we're gonna place you in an apparatus. Okay, then we're gonna flip you upside down while you're playing the drums. Okay, and then we're gonna set that apparatus on fire. There's like, where do I sign? That's fucking awesome. Playing the drums upside down while on fire. Hell's fucking yes. A strong word to use in this context. Isn't that a little much?
No, you're scared to suffer.
That's what you got.
I don't think that's what he's necessarily saying. I kind of get where you're coming from, dude. It just the orientation of it is very problematic because it's very inverted. Blood, gruel, all the negative things. So yeah,
it's
like
basically about dealing with the negatives in a positive way.
You're so scared to suffer. Why are you so scared to suffer?
Scared to suffer what?
Yeah, suffer. Why are you upset when bad things happen to you? What does it even matter? You don't believe in anything being bad or good.
Dude, there is no quote unquote scared to suffer. After all, I'm in the Discord server right now. The fuck you talking about?
You're absolutely scared to suffer because you think it is absolutely correct to tell someone to fuck off because you're scared they're going to make you suffer.
No, they're just going to be annoying and probably like
cause you suffering.
Suffering would
You're
be
a wuss, dude. You're a wuss. You're a wuss. It's been proven.
Suffering would be the strong word to use in this context. Isn't that a little much?
No, you're scared to suffer.
Because in real case, like if you find someone annoying, I guess you're suffering. Yes. If someone steals your money, yeah, I guess you're suffering. But I wouldn't use the word suffering. I would use the word theft or annoying or liars or something like that. Suffering.
And what are all those things? What do all those things cause?
Like suffering
would. What does theft and annoyance cause to people?
Like suffering would invoke.
Yeah, dude. It causes suffering. Like yeah, thank you. You're exactly right.
I would use it to describe like electric shock, waterboarding. And by the way, fun fact: did you know it's not waterboarding if you use diesel?
So crazy fact. Did you notice how you always go off on a weird tangent whenever you get caught on something? But all those things you just mentioned, everyone would agree causes suffering. Does anyone in this room
they wouldn't use that
having their stuff stolen from them doesn't cause them suffering? Oh, they wouldn't use that word. What word would you like to use, Prissy?
How about stolen? The fucking word.
Make a point of them being inconsistent. I'm only going to ever call them out on a belief that they can't prove. I'm not going to say they're not making logical sense within their imaginary frame.
I was talking first, so let's go ahead and try this again before I was rudely interrupted.
So yeah, you're done. I just demonstrated my point clearly.
You guys are just going to start the same shit again, aren't you? You're going to start the same shit again.
I'm going to do it again to prove my point.
Let's see.
I'm going to short circuit this shit right now.
Let me go ahead and try and get it out, and you tell me. So, as I was saying again,
is this causing suffering to anyone?
Because it's so self-obsessed.
The same situation. So, if you use the word suffering, that indicates more severity. And if you use different words, which can be used in the same sentence, that would indicate
how much this guy cares about a 9 point.
So, given that fact, words have meaning, context has meaning. indicate the severity of the sentence. So if I came to you and I said, hey, you need to come save me, I'm suffering, that indicates a different severity than, hey, you need to come save me, I'm annoyed right now. I'm probably going to stop at the stop sign every single time on my way there.
Okay, there you go. Now go ahead, Torah.
Thank you.
Yeah, I already demonstrated my point. It's obvious to everyone in this room when I interrupted Red's rhetoric and was talking all over him that was causing suffering. And what it started off was as annoyance. And it made you guys suffer so much that you had to come on the mic and tell everyone how much this is causing suffering.
Actually, your shitty mic was producing way more suffering than you. No, I wouldn't use the word suffering in that case, the word annoyance. But yeah, you could brute force the word suffering into that situation, and I wouldn't be stopping you. You didn't actually prove anything. You just
Okay,
proved
cool. That was my whole point. So
you can
now
take
we
the
agree,
more
and you've conceded
you
to
can
my
use the
point
more
that being
extreme word.
annoying can be
You can
suffering.
use the
So
more
therefore,
extreme
if it
word.
is
You can use the more extreme word. You can use the more extreme word if you want. But I prefer to be clear as to what I'm trying to say, and that includes conveying the severity of the situation. What you're doing right now is not all that severe, so I wouldn't use the word suffering.
Okay,
Annoyance is a
awesome.
subset of
It
suffering.
boils down to definition.
Let
How you
Torah go.
define.
Torah was definitely waiting to get in. Everyone was done talking. It's Torah's turn, and then Asko's next. Right? As you, Asko?
Yeah, but no big deal.
Yeah,
Torah will
Torah
get
and
it.
then Asko. Go ahead, Torah.
Okay, cool. So the start of this conversation was this gentleman, Red's Rhetoric, said that he can hide in telling someone to fuck off. So I said to him, yeah, because you're scared to suffer, right? And then he said, no, if the person's just annoying, I would just want them to fuck off. So I said, yeah, because you're scared of suffering. And then he claimed annoyance isn't suffering. But in his last statement that he made, he said, yes, you could do a reductio to turn annoyance to suffering. He just doesn't prefer it that way. So therefore, my claim stands, and the gentleman has not refuted the claim that he is scared to suffer.
Lovely. Who's next?
Yeah, what Torah
Okay.
said. Annoyance is a subset of suffering, obviously.
Yes. It was all
Wait,
about
wait. So
severity, which apparently Torah doesn't to understand with my thing. So everything he just said does not in any way, shape, or form debunk what I just said, which is different severities depending on the word that you use to describe the situation. Now, if Torah wishes to
shit
argue
music.
against that proposition,
Shit music is
I
a
would love to
suffering.
hear it.
Riksky,
But if
please,
Torah is
guys, hold
unable to
on, Red.
argue against
Red,
that
hold on, man. A
proposition,
moderator. Red, when I try to step in, don't just keep going, please.
I didn't
Guys,
hear you.
I know. All right, you can hear me now. Rick, guys, don't interrupt, please. It's a fucking shit show. Rick, you sound like you're about to fall asleep, bro. Go ahead, Red.
Thank you. I appreciate it. So again, nothing that Torah just said actually debunks what I just said. Is different severities with words, all right? And using the correct word for the situation will correctly indicate the severity. So I gave an example. If Torah were to call me and tell me that he was suffering at a particular location, I would probably be breaking the speed limit, running stop signs and traffic signals to get to him to save his happy ass. But if he said, you need to save me, I'm annoyed right now, I'll still pick him up because I pity the guy, but I'll probably stop at the stop signs and look both ways and that kind of thing. Maybe follow the speed limit. Maybe I'll pull over and get some lunch, along the way. It all depends about using the right words for the situation, and the severity of the situation has to be something that we take into account. So yes, you could use the word suffering. Annoyance does mean suffering. You are right. I never said you were wrong on that. I just said that it would be the wrong word to use in this particular situation because it would convey a severity that is not actually the case.
Okay,
Understand the
awesome.
difference?
Yeah, I understand what you're saying. And I think that it's incredibly interesting that you would actually take this much time to go into this topic. And then you still didn't even do the rebuttal to you are scared to suffer. You still haven't proven that you're not scared to suffer. We all know it, obviously, because you think it's justifiable to say fuck off to someone that's being annoying. So that way you don't have to endure the suffering, because enduring suffering makes one stronger and you are terrified to suffer. So therefore, you are a pussy See, sir.
If you don't want something, does that mean that if you don't? No. Answer the question. If you don't want something, does that mean that you're scared of it? So, Torah, answer the question. If you don't want something, that means you're scared of it, according to you, right?
Nope, not in all situations. In this specific situation, that you think it is possible to tell someone and justified to tell someone to fuck off because they are annoying, it proves the point that you, sir, are terrified of suffering because everyone knows that suffering makes one stronger. And if you were to deal with that annoyance, you would actually suffer a little more and then become stronger in dealing with it. But instead, you justify saying fuck off. Therefore, this is the conclusion of the argument. You are a pussy.
So notice what he just said there and how it just did what he just said. So if I tell someone to fuck off and me not wanting to deal with them, he classified that as me scared of it. But he said, no, not wanting something doesn't necessarily that you're scared in all situations. So he made a claim that something is an absolute while leaving room for it not to be absolute in actuality. So Torah, square the circle for me. How do you get past that logical contradiction?
Yeah, no problem. In the situation of someone is being annoying and you can justify telling them to fuck off, it's objectively the case that you are a pussy in that situation. Okay, so you have a subjective situation, and in the subjective situation, there's an objective truth of the matter. And the objective truth, wait for it, if the conclusion is you are a pussy. Oh yeah, true that. What do you think the difference between death and going to sleep is?
Sleep is like no. Sleep is death with benefits.
I think the difference between sleep and death is like being blind and closing your eyes. Oh, it's fire, bro. Write that shit down.
That was good. Yeah, someone needs to write that down. That was a good one. But what do you think?
Is like being blind and closing your eyes. Oh, it's fire, bro. Write that shit down.
That was good. Yeah. Oh yeah, true that. What do you think the difference between death and going to sleep is?
Sleep is like no. Sleep is death with benefits.
I think the difference between sleep and death is like being blind and closing your eyes. Oh, it's fire, bro. Write that shit down.
That was good. Yeah, someone needs to write that down. That was a good one. But what do you think? Like, what if it is the case that death feels exactly like going to sleep?
Then
why would you be scared of that?
That's going to be the best power nap ever.
Yeah. So if it is the case that death is just like going to sleep, then why are you scared of it? That you want to download your consciousness somewhere or something?
Well, because let's face it, the world needs more of my awesomeness. So why would I want to deprive you guys? That would just be cool.
From claiming to be wise, they became fools.
So if I were to not have my consciousness, then you would say, hey, look at all these winners that are left over after the rapture. We need losers to compare ourselves to. And if I'm such a loser and you're download my consciousness to the robot body.
I don't have that worldview. Whatever you just tried to insert into my worldview, if I don't have that.
All right, cool. Then you should have no me downloading my consciousness to wherever if it doesn't affect you.
Yeah, download it up, bro. Download it. Live out your life, your 80 years that you have decided to reject God and then just enjoy the worldly pleasures for just 80 years, bro. More power to you. The funny part is you're still abiding by God's law.
And how about you said you like planes? How about this other? Have you heard about the 2026 Great Train Track debate? Let me tell you the Great Train Track. I'm going to tell you the Great Train Track debate is this, right? So, two people are two positions at the equator, parallel to each other, and they walk or travel by whatever means in a straight line south. They will converge at the pole. Is this correct?
No.
Straight line down, like they're going due south, exactly due south. Yeah, eventually they'll converge.
Yeah, and those are straight lines, and the reason that they're converging is due to the nature of the sphere. Is that correct?
Yeah, I mean, we model lines of longitude as parallel when we put it on, a Cartesian plane, but a sphere is different. Like, for example, we're all taught in school that a triangle, that if you add up the angles, it comes to 180 degrees, and that works for a two-dimensional plane. Now you go into 3 dimensions, a triangle drawn on a sphere has different rules.
Very cool.
Yeah,
Very cool. So,
still a triangle.
all right. So you agree that lines of longitude are straight, but due to the nature of the sphere, they converge. So they're parallel lines initially, but the nature of the sphere will cause them to converge in going south. Is this that you agree?
Nature of the sphere. What the fuck
Yeah,
you talking
if you walk
about?
south, you're going to run into penguins. I agree with that.
Right. Okay. All right. So that means, right, the Earth being a sphere in all locations, that means that any two
It's not
parallel
a
lines
sphere,
on the
bro.
surface of the Earth will converge. So now you have train tracks at different locations on the surface of the Earth that do not converge in other directions.
Oh my god. Oh my god.
Okay. So therefore, there's areas on the Earth's surface that are not a sphere, because they're not causing two parallel lines like train tracks to converge. So it's
Therefore,
only
they're
a
not
sphere
a
in one
sphere.
location,
So two conversion
in one
lines
direction.
will not make a sphere. Therefore, they are a sphere.
I don't
All right, so 2 positions on the equator. You tell me when you disagree.
Stupid.
2 positions on the equator will converge as they go south. That's a straight line. Those are 2 straight lines, but due to the nature of the sphere, it'll cause the straight lines to converge. And
What sphere?
right, so that's due to the nature
exactly a
of
line
the
of
sphere.
latitude, just for simplicity. Yes, I agree with you, or I will stipulate that they will converge.
Yeah, due to the nature of the sphere, right? So
Yeah.
yeah. So now the Earth is a sphere in all locations, right? Is this correct?
Oh, well.
That's like saying a square is a square in all
All right.
locations.
So I just want to make sure you're on board. So since
Are you
it's a
asking me
sphere in all
if
locations,
We're on board, yeah.
Yes,
Yeah,
it's
it's a
a
sphere, bro.
two-dimensional sphere.
Yeah, so that would necessitate.
Yeah, it's
Yeah,
like
so that would
ball, bro.
no problem. So that would necessitate that all parallel lines in any direction will converge. Train tracks are 2 parallel lines in other directions, other in a straight line, and they do not converge over any distance.
And you know this how? Because lines
Because
of
the
latitude
train
are
because
parallel.
because the
They will
trains ride on
converge
the
at the
tracks in all
bottom.
directions.
You're thinking two-dimensionally still.
Am I now?
Welcome
Yeah.
to Fire.
Yeah.
Longitude lines aren't parallel.
All right. All right.
They
Well,
are
listen. We had.
parallel, but they will
Not on a
converge
sphere.
on a sphere. In
No.
Cartesian coordinates, they are
Longitude lines
parallel.
are not parallel.
I think
Welcome
you're
to
not
Flat Earth.
understanding the difference
Longitude lines
between
are not parallel.
where we're drawing it.
How do you know they're not parallel?
X and Y, yes, lines of longitude are parallel. But if you take those parallel lines and wrap them around the globe, now we will still geometrically call them parallel because they are parallel to each other. However, in this case, they actually converge at the top of the sphere and at the bottom.
Parallel lines, by definition, I mean longitudinal lines on the sphere are not parallel. No, they're not.
Again, most of us have looked at a Cartesian map. Yes, they are not parallel. I mean, they are parallel on 2 dimensions, but on a sphere, we still say those are parallel lines. But now you've added a different part of the geometry. Parallel lines will meet at the top and at the bottom. Lines of latitude will not. I mean, would it
And
make
this is
it
what.
easier
there are
to call lines of latitude
parallel
parallel?
lines.
Would that make it
Hold
easier?
on a second, dude. Hold
Nobody
on, man.
says
Can you guys hear me?
longitudinal lines are parallel.
Can you guys hear me?
Yeah, that dude right there, Thermo is saying that lines of longitude are parallel, is what he was saying.
Yeah, there are no, even
Not
in
real.
spherical geometry, there is no geometry where there are parallel lines on the surface of a sphere.
Well, Well, latitude lines are parallel on the surface of the sphere, but longitude lines are not. And nobody
Nope.
says.
Latitude lines. There are no parallel lines in spherical geometry. There are no parallel lines.
Latitude lines are parallel on a globe. Longitude
You don't know
lines are
spherical
not.
geometry then, Cole. Cole, you don't know spherical
What?
geometry. In spherical geometry, there are no parallel lines in spherical geometry.
Yes, there are parallel lines in spherical geometry.
Oh my
I
god.
can find you 100 citations saying what I'm saying. Why don't you find me one that says what you're saying?
Because latitude lines are parallel on a globe, Jeremy.
They call them parallel because they're equidistant from one another, but strictly speaking, they're not actually considered parallel geometrically.
Why would they not be?
Well, they're different. They're different
Because
circumference.
they're
Each
not in the
one's
same plane.
a different plane. It's you'd have to read the postulate
Dude,
to understand.
Anyway,
the definition of parallel is
say
equidistant.
it is in spherical geometry.
Let's
or
just
not.
say parallel.
The way
Okay,
it's-
they're
the
not
way it's
parallel.
laid-
Let's
the way
let's
it's
just okay,
laid
they're not
out.
parallel. If you can go, so we would say you're looking 180 degrees.
Okay. What now? Do people hold contention that eye level, like the line of sight of your eye, would deviate from surface direction? So what I mean is that if we were both standing at the equator, looking at the Southern Cross, right? Would that deviate? Would that be would that be converging lines to a point? And if so, would that in free space? Right. I'm just looking at it. We're going to converge there in free space. Is that going to differ from the surface of the ground?
I don't know what you're talking about. Eye level.
Are we looking at a point? So we're going to go to a point, and we're going to call that a sphere because we're all going to a point.
Okay. Sorry, are you saying that, like, for example, let's say we're looking at the Southern Cross, and as we sort of start walking down, would the position of the Southern Cross be in different places? Is that what you're saying?
No, are we just we're just walking to a point. So and we're calling that a sphere. Is that what's going on? So they're all these lines of longitude. They're just a straight line to a point. So that's how you know they're not parallel. I don't know. A bunch of people chimed in. They said they knew they are parallel. They're not parallel.
To
I'm
make
asking how
life
they know that.
easy, the answer is on a two-dimensional map, they are parallel. On the globe, they are not.
Yeah, but if so how do you know it?
Observation.
All right, what are you observing?
Well, I have never tried to prove to myself that the Earth is a sphere, but even I've observed that this could only be a sphere. Temperature differences between the south and the north.
Oh, I thought you were the plane guy.
That's it.
The position of stars in the sky does change.
Have you heard? Like this is like a simple thing, right? Like if I stand under the recessed ceiling light right here in front of me, right? I'm gonna point straight up to it, right? And my ceilings are 10-foot ceilings, right? I'm gonna point to the ceiling light that's 90 degrees. I'm gonna take 2 steps back away from it, right? And then but I'm gonna keep pointing at it, and then my arm's gonna point now down at now like 80 degrees. Now make another step back, 70, 60, all the way till it's almost converged with eye level. But the light in the ceiling never actually got lower. I just moved further away from it.
Because the light in the ceiling is on the same curve you are. It's pretty simple.
No. All right. So what caused it? What was the cause? The effect was that in order for me to keep pointing at the light, I had to pivot or get a different elevation, a different angle of elevation of my arm to the light in the ceiling of my house. What was the cause of that?
So you're walking on a curve.
Yikes. You think that my room is a globe?
Sorry, I think your room is what?
A globe. Like I'm like at the end of my hallway over here, and I'm pointing at pretty much like I don't know what is this, like 30 degrees. If I had a protractor like in my hand, I'd pretty much be pointing at 30 degrees. You think over the span of 30 feet or whatever this is to my ceiling light, that's dropping at, I'm down, I'm lower, I'm on a curve.
I see I see your explanation. How much does it drop by?
Like I
Have you
said,
done this experiment?
maybe like 50, 60 degrees. I don't have a protractor on my arm right now, but I'm pointing pretty forward.
Yeah, I
I
think you've
was right.
done something wrong. You're doing something wrong in your experiment.
I'm right. I mean, dude, you could do it in your house. Get
I mean,
underneath of a ceiling.
the size of your house and the size of you are insignificant to the globe. That's why we don't feel the effects of it. I mean, I look outside, yeah, it looks freaking flat.
I think we do feel the effects of it personally. I think that's why babies have a hard time walking when they're really small. You know, they don't know how to walk because they're getting used to the earth spin and wobble.
No, the rotation is traveling at a constant speed, so it might as well be still. It doesn't. We won't feel anything. Evolution
Tell that to
is
the baby that's stumbling all over the place, dude. That baby feels it, bro.
So you think if that baby was on something that wasn't rotating, it'd just start dancing like Michael Jackson as soon as it's born? Or
That's right.
Or
You see the new movie?
That would mean. What if I put my baby at the exact North Pole, the geographic North Pole? Would you still have that problem?
No.
Well, then, if you have that baby at the North Pole and then that baby is looking at the sun, will the baby have to turn?
We're talking about wobbling right now. Would the
Well,
rotation of the Earth
I don't know. Have we real quick? Have you resolved this ceiling light? And you said because my house is a globe. I mean, have we resolved that?
I don't understand your experiment.
You're standing underneath of a ceiling light, right? You're pointing straight up to it. Straight up to it would be perpendicular to the floor. That would be 90 degrees.
If you put your data in the side chat, then we can evaluate it.
Bro, are you serious? Go to a ceiling light right now, or I will never talk to you again.
Well, you see, that's the problem with the flat Earth community is they think they're doing experiments, but then when I ask for data, you think that's silly. That's
Dude,
how
are you
science
joking?
works.
10 foot ceilings, 2 steps back. 10 degree. Now I'm at 10-degree difference. What's going on?
Yeah, if you
What other data do you need? Go do it in your room.
Oh God, yeah, show me your data. I think your experiment's flawed.
Show you my data. What do you do? A ceiling point up, then walk there. Wherever you pointed at with a laser. Use a fucking laser. Are you joking right now? Are you fucking joking?
It's just a thought experiment. I mean, he don't have a paper written on the thing. He's just trying to tell you a thought experiment. He wants you to go through.
Yeah, it is a thought. If we treat it like a thought experiment, I'm having trouble conceiving it. That could be a failing on my part. It probably is.
How about this thought experiment? Because you like the North. You can imagine the North Pole. Right. And then I'm going to probably drop out because I don't know if you can't imagine this one. All right, but all right, you're at the North Pole, right? And you have a compass that points to magnetic north. I've never been to this place, but they say it exists. If you want to stay east, will you be doing a circle around the North Pole?
The black people.
I'm sorry, I wasn't listening.
Oh, God. All right.
If you want to repeat it, that's fine. I'll listen. If you don't, that's okay.
Nope, I'll drop out. All right, I'll try. I feel like you're giving up, so I was going to drop out. All right, I'll try one more time. All right, you're this thought experiment, right? You're at the North Pole with a compass, a magnetic compass, and a magnetic North Pole. I've never been there. This is what they say. Now, if I want to maintain a heading of east, and I'm only 10 feet away from the North Pole, that's right. I put a literal candy cane in the ground to mark the North Pole. Like, there it is. And now I want to maintain a heading of east. Will I go in a circle around the North Pole?
Depends.
There is no east at the North Pole. Now, if you walk 90 degrees, and let's say we'll call that east, no, it will feel like you're going in a straight line.
Okay. If I don't know why you said there's no. I'm 10 feet away from it. Did you hear that? I'm 10 feet away from it.
Yeah, 10 feet is insignificant to treat the surface of the Earth as a
you're
as a
just
curve.
making shit up.
Okay, so I'm just asking. In reality, if I'm standing at this magnet, and my compass points to this magnet, and north, and we call that where it points, we call it north, and I want to maintain a heading of east. That would be 90 degrees to north at that point. Will
If
it
you
just
want to be
take me in a
pedantic
10-foot?
about that,
Would it just take me? Would it just take me in a 20-foot diameter circle, like a 10-foot
if
radius
you want to
circle?
be pedantic about this,
you'd walk in a
if you're
circle.
standing at the geographic North Pole, the only direction you can go, if you walk in a straight line,
No, 10 feet
is
away from it.
is south. That's it. 10
10
feet
feet
away
away
is
from it.
insignificant.
Okay, well, it's happening in reality. So in reality, am I going in a circle?
It's insignificant in reality.
Okay, I will drop out. I will respect your wishes.
I don't
It's
want you to drop out.
definitely significant in reality because that 1 degree drop per radian was measured exactly the same way.
What the other dude was saying a while ago, if we was in a computer world and the geographic north or the magnetic north pole was a point, like just this point, not fuzzy, not you have to be so far away before you start, but it was just a point. You stood 20 foot away from it, and it would literally make your magnet point the north part to that point on the ground 20 foot away from it. What he's saying is, then if you turned east and you walked east and you wanted to maintain east, would you have to walk in a 20-foot giant circle around that point to maintain east? That's what he was trying to say.
Sounds about right.
Obviously, in real life, you got a lot of factors that come into play. You got
Like
fuzziness,
black
things,
people.
but he's trying to just
Black people.
simplify it down. Let's put it
It's
that way.
terrible.
That's how I look at it.
Can you run a country with black people?
In blood.
I'll get that right out. I'll get that right out.
Yeah, you gotta do that. I can't believe it took you looking it up to be convinced of that. Like, dude, it's Jeremy, bro. Just believe him. Everything Jeremy says is true.
Yeah, it's so I heard.
And yep, and that's what I was saying for Jeremy in this, right? So when eye level, like a line of sight, would not be on the surface of the sphere, right? So that should be straight. That should deviate from the longitude in their minds.
Yeah.
That's a good point. Yeah, that is a good point. So, line of sight is straight, looking north. Yeah. What do you do with that? What are you guys going to do about that? Is that why the Earth looks like a disc with upturned edges?
Upturned disc.
Yeah. So if somebody's saying, well, listen, I'm going to get a direct line of sight. I'm going to look at Polaris, right? So that's distinct from the surface of the Earth. That should be a different path traveled than on the surface of the Earth.
Should move, right?
But how is it that they match in their minds? How are they saying, look, all I have to do is keep on looking at Polaris and it's going to match where I'm walking? The line of sight for my eyes is going to match the surface of the Earth. It's impossible.
Yeah.
Did you play video games when you were a child?
I'm not
asking this in a bad way. I'm just.
Dude, what do you think about that though? Like, what's the rebuttal to that? What does the globe have to offer to explain the difference between the line of sight and then the line of walking? This is you're walking the line here. What are you going to do about it?
Greater distance. If you're only walking 10 feet, that is an insignificant amount of change. But
no, it's not 10
at
feet.
the North Pole, the
Dude,
only
it's
direction
69
to go
miles.
is south. You can't go east. You can't go west. Now, in the little local area, you want to walk around in a circle. That's fine. But that's...
Wait, do you agree 69, like, do you agree 1 mile is from point A to point B, 5,280 feet?
Sure.
That's a linear distance, right?
Yeah, we will model
Okay,
a straight
yeah.
line.
So now if we do 69 of those, if we get freaky and do 69 of those, that thing changes by 1 degree.
Don't measure the length of a line with a degree. Measuring a line is a one-dimensional.
Yeah, so what are you even doing with taking angles to the stars? How'd you get the measurement? You're exactly right. You can't get a measurement from a degree. So how are you saying the Earth is a globe if we take that away?
Those two statements don't make any sense. If you want to know why stars move in the sky, I can explain that to you. But
okay, if I move along the Earth, right? I just move along the Earth, and then I record Polaris, and it changes by 1 degree in my sight while I've been moving along the Earth. How the hell did you determine that was 5,280 feet?
Well, okay. So the first thing is
this is like how long is a day? I understand.
How we determined a mile was arbitrary. That's why in science we use the metric system. But a mile will always be a line. A kilometer will always be a kilometer. And you mentioned Polaris. Polaris, I see where you're getting confused because Polaris should be at the North Pole. I think that's where the confusion is coming. And I get that.
Polaris is the geographical North Pole.
Yeah, and you only have 90 degrees from Polaris to the
where you're getting
equator. That's a
confused
90-degree angle.
Yeah, where you're getting confused, you got to remember Polaris is it's in space. So that's different.
Do you agree that the geographical North Pole that we call on the Earth is a place that we determined by the sky looking into space? And then we said, when we're 90 degrees below this thing that's in space called Polaris, we call that the geographical North Pole. Do you agree?
Polaris was not, I don't think it was used as an experiment to determine the world is round. However, Polaris is important in navigation.
Well, everyone knows the world is round. I go around it, you go around it. Life's like a circle. Hills are rounded. You know, if you don't want water in your house, you're going to make it a little rounded so that way you don't have any water sitting in the middle of it. So, yeah, I mean, if you're going to claim, oh, because all of that stuff is rounded,
truth.
You know, therefore Earth's rounded. Okay, yeah, I agree.
Yeah, in my neighborhood, most of us don't have round houses.
It's definitely not flatter than 8 inches per mile square, your house.
Hey, non sequitur. Doesn't make any sense. You're trying to say something.
Do you believe the rate of roundness on the Earth is 8 inches per mile squared?
Is it? I actually don't know that.
He's right.
I have to look up.
Everywhere I measure, I'm getting way more than that. I'm getting like, dude, a lot more than that.
Are you trained in how to measure such a thing?
Yeah, 8 inches per mile squared. That's a slope. That's a slope. Yeah, that's a slope, like a parabola. You know, like a parabola. So, like, I understand. So now, when I go to the beach, it slopes out of the water, and I measure that. It's curving way more than 8 inches per mile squared.
How are you measuring it?
With measuring devices.
What are those devices called?
Tools.
You're not using a device. Come on.
Hey, which one of you is the flat earther? Because I can't tell.
I personally believe the Earth is shaped like a tetrahedron. Nobody's been able to prove me wrong.
So you say. What is that shape? Because I have no clue what that is.
Hey, there's my best friend. What's up, Bessie?
Like a diamond, like a pyramid. You stick two pyramids onto each other. I think that's a tetrahedron. But that's the shape I think the world is.
Hey, let me ask my best friend something real quick. Hey, Bestie, can you imagine this scenario? Right? There's a ceiling. I have a recessed light in my ceiling, and I stand right under it. And if I point up to the ceiling light, that'll be 90 degrees. But if I take 2 steps backwards and keep pointing at the ceiling light, my arm is going to go down. It's
This
going to
guy
be like 80
raised
degrees.
by the way, so just mute him.
No, stop that. I would never do that to you. That was a British guy.
Right.
And then imagine I take 20 steps, 20 steps, and it was consensual what we did. It was love. 20 steps back, then my arm's going to be pointing almost straight out in front of me, right? Can you imagine that if I just keep pointing at the ceiling light?
Yeah, I don't know, man.
Oh, my fucking
Hey, bro, can you not cough into the mic like that, dude? Is it cool if you go on mute for that? If you could, like, just sit on mute until you want to
I didn't
talk, that'd be
realize.
great. Like, so if you could put your mic on mute while you're not talking, that'd be great.
Yeah, I didn't realize the cough was that bad. It kind of just came out of nowhere.
Like, I thought you would be able to imagine it, TLB or whatever you are. The other guy couldn't imagine it. He can't imagine
what you even just said to me.
What's that? All right, here, let me just
I
walk
didn't
you. This is just like a demonstration. Let me walk you through the demonstration real quick. You ready?
Sure.
All right. I'm going to demonstrate that I can change my angle to this light in my ceiling without my floor being curved. Right. I'm going to level my floor. Right. I'm going to level it out, and then I'm going to put a ceiling light 10 feet above me, and I'm going to point to it. All right. And then I'm going to take a step. I'm going to keep pointing to the ceiling light, and I'm going to walk backwards on my level floor. And as I walk backwards, the elevation angle, where my finger that's pointing to the light, is going to get lower and lower as I walk away from the light, proving that it's not necessary
Okay,
to have
I get what you're
to
saying.
measure a change in angles.
Yeah, I get it.
But Lobster needs to get it. Lobster, do you get that?
Yeah, I see what
The
you're
same
talking
thing would happen on a flat
that
Earth.
proves
by the way.
anything.
The same thing would happen on a flat Earth too.
Okay.
Has nothing to do with the
Awesome.
Earth being a sphere.
So you think
Proves
the Earth's
nothing.
flat?